This is the Fibonacci series. So Fibonacci written above, and we have usually written this down. This series, which is S is equal to S. We have taken S for the series. So S is equal to 1 plus 2 plus 3 plus 5 plus 8 and so on, up to infinity. And the Fibonacci series is a very can be formed through some very basic arithmetic. The in the Fibonacci series, each term of the series is made by adding the previous two terms of the series. For example, here you have 2 where this let me just outline that in a new color. Here you have 2 in this yellow box, and 2 is formed by adding, and 2 is a sum of 1 plus 1, 1 and 1, and so we continue in the same fashion. We get through, and so here we have 3. 3 is the sum of 2 and 1. So 1 and 2, 1 plus 2 equals 3, and then 2 and 3 you get 5. This 5 here, and 5 and 3 you get 8, and you can repeat this pattern up to infinity. It is for all positive numbers. So what? Since each of the terms, this is a series, because it is a series because it has this plus sign in between each of the two terms of this Fibonacci sequence. So what I'm trying to say is that since these numbers keep increasing, afterwards you add 8 and 5, you get 13 plus 21 and 34. So you might expect that so you would just say that this series will grow up to infinity, and yes, you are right that this series, that the terms grow to infinity. They go to infinity as the number of terms in this series go to infinity. So you might also think that since each of the terms goes to infinity, then the answer of the sum of each of the terms of this series should also be infinity, right? Well, this is what I'm here to prove, that it does not go to infinity. It converges at a value. So converges at a value. So basically, converges means that if you add all the terms of the series, if you add all the terms of this infinite series, then you will get a value, a number. So what is that number? So if S converges, then it means that S is definitely not equal to infinity, right? S is not equal to infinity. S is not equal to infinity. Well, what it is equal to? So let us try to find that out. So let me write that series again. S is equal to 1 plus 1 plus 2 plus 3 plus 5 and so on. That and so on is just as important as all the terms of the series. Now we decide that we are going to add another S. So you might say that, okay, you add an S on this side. You also add so S is equal to 1 plus 1 plus 2 plus 3 plus 5, like this, and on to infinity. And so you would expect S plus s is equal to 2s. You must think that it will be equal to 2 times 1 plus 1 plus 2 plus 3 plus 5 and so on up to infinity, 2 times this whole series. So that is generally what you might think, that's how it would turn out. And basically the answer of this series would be infinity, right? So was I telling you wrong? Well, actually no, because if you, let me just write that for the third time. I mean, that is 1 plus 1 plus 2 plus 3 plus 5. If you add an s, now we are going to add and to another s in a different way. What we are going to do is we are going to put 1 plus 1 plus 2 plus 2 plus 3 plus 5. Oh, I forgot to put and so on. So let's just take it till here. And well, what do you get now? What do we get now? We get 2s is equal to 1 plus 2 plus 3 plus 5, oh my, plus 5 and plus 8 and so on. So well, how did I calculate this? Well, you have if you can assume that there is a 0 beneath this one. So 1 plus 0 would be 0, 1 plus 1 would be 2, 2 plus 1 would be 3, 3 plus 2 would be 5. So what we are doing is essentially that we are adding to each term of the Fibonacci series, we are adding the previous term of that Fibonacci series. So that means if we add 1 to both sides, then we get 2s plus 1 equals 1 plus 1 plus 2 plus 3 plus 5 and on up to infinity. And well, then this series must be equal to s, right? This series must be equal to s. Let me just outline that series. This series must be equal to s, right? So can't we just substitute s in this place and see what happens? Yes, let's do that. So we get 2s plus 1 not a very good plus sign, plus 1 is equal to s. Now we subtract s from both sides. We get, this is basic algebra, so s plus 1 equals 0. Now and this is the conclusion of this thing. S, we transpose 1 to the right hand side, we get and this is the conclusion. S is equal to minus 1. And let me just outline that. Therefore, this means, this means that the Fibonacci series 1 plus 1 plus 2 plus 3 plus 5 plus 8 is equal to minus 1. Well, that is actually a lot of surprising thing. So hope that such a revelation will make you a good day.